Okay, so today we're going to be talking about the unit circle and radians and also degrees. So first off, what is a radian exactly? Well, it's a unit used to measure angles. So it's sort of like degrees, but it's not really, because you have to put it in terms of radians, but there's always going to be a pi in the number. So let's see, how do you find a radian? If this pi is a unit circle, so we'll just draw a circle right here with a radius of 1, because that's what unit means, right? 1. And radian is the angle formed right here if the arc length here is also 1. So just 1's all around, like this. And we can find that really easily because the radius is 1, right? So what is the circumference? It's just 2 pi. If we just call this arbitrarily x, then x over 360 equals 1, because the arc length is 1. So that would mean that x equals 180 over pi, and that's basically what a radian is. So every time you say something radians, you're actually saying, you're putting it in terms of this number right here in degrees. And we can make that make sense, because what would this angle be? If this was 180, right, then what would this be in terms of radians? It'd just be pi radians, right? Because this is 180 over pi, so if you have pi radians, then you just multiply that times pi, and then you get 180, so that makes sense. So this is pi in radians. So let me just write right here, 180 degrees equals pi radians. Now what would this be? 90 degrees, so 180 over 2 is 90, so pi over 2 is just pi over 2. This is pi over 2. 45 degrees, what is 45 degrees? 45 degrees is half of 90, so what's half of pi over 2 is pi over 4. Now you can split this up even further. You can say pi over 6, pi over 3, and we're going to be using those a lot. So pi over 3 is 60 degrees, and 30 degrees is pi over 6. And so what would this be? 2 pi over 3. This would be 3 pi over 4. This would be 5 pi over 6. Now, you're going to have to memorize this because your teacher's going to make you memorize it, regardless of if you want to, because it pops up everywhere. Like, literally, it pops up everywhere. It could be on a random quiz that has nothing to do with it, and they'll just put it on there just to, yeah. So you better memorize it. Okay, this is 3 pi over 2. This is 0, right? But it could also be 2 pi, because 360 degrees, so 360 is 2 pi, so this could be 2 pi. This could also be 4 pi, and it could also be 6 pi, 8 pi, whatever. So what they call this is 2 pi k. If k is a random constant, then no matter what you multiply it by, it's always going to be a multiple of 2 pi, and it's infinite. Like this, remember the coterminal angles? So like we talked about that, right? This is 360 degrees difference, but it's also 2 pi difference, because remember they're the same thing. So these are all coterminal angles. Yay. Okay. I don't think I'm going to fill all that in, because you can do that in your own time. Okay, so I just zoomed in into the first quadrant so we can get a better look at the unit circle. So I'll just redraw it right here. We only need this part, so for right now anyway. Okay. So, as you know from your previous lessons in geometry, you have SOHCAHTOA. So sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Now, in PRECAL, that you use that a lot. And for the unit circle especially, that's like a main part of the concept. So let's say I draw a random triangle right here. That's maybe not so random, but we'll just say it's random for now. This is a right angle, so this applies. We'll call this theta. And this is 1 because that's the radius of the circle. So sine would be what? Sine of theta. Sine of theta would be opposite over hypotenuse, right? So if we call this y and we call this x, sine would just be y over 1, which is y. Cosine theta would be adjacent over hypotenuse, so x over 1, so that's just x. And tangent theta is opposite over adjacent, so that's y over x. Now you're probably wondering what the y's and the x's mean. Well, watch. Okay, this is really cool. So I'm just going to delete that. And let's say I draw a 60-degree angle right here, and a 90-degree angle, and then a 30-degree angle because that's the last angle, and that is a special 30, 60, 90 triangle. And so you know this is 1, right? Because that's the radius. So if this is 1, what is this? Half, right? Because this is 2 times this, so this must be half of that. So this is half. Okay, now what's this? Remember, to get from here to here, you multiply that by the square root of 3. So half times the square root of 3 is just square root of 3 over 2. And this just happens to be pi over 3, remember? Because 60 degrees, so 180 over 60 is 3. So then pi over 3, because pi is 180, right? Okay, so 30 degrees, 60 degrees, and the right angle. And now you have the x and the y, so you can easily find sine and cosine of pi over 3. Because sine is the y, remember? So sine of pi over 3 is just the y value. Because remember the y over 1 thing? So square root of 3 over 2. Sine of, what is this? Pi over 3 again? Wait. Okay, cosine of pi over 3 is half, and tangent of pi over 3 is, what is that? Square root 3 over 2 over 1 over 2, so that's just square root 3. Now, you can, okay, as you can see, the pi over 3 just substitute into theta, because theta is pi over 3. Because remember, the pi over 3 is the degree angle, only it's not degrees, it's radians, but it measures the angle here, so this is pi over 3. Does that make sense? I hope it does. Okay, so do you want to try out another one? So let's see if we delete this. Okay, just a hastily drawn one. Shit. Okay, let's just call this 45 degrees, which means this is 45 degrees too. So it's the 45, 45, 90 triangle. And that means that whatever this is square root 2. This is square root 2 over that. So that means that if this is pi over 4, right? Because we established before that 45 degrees is pi over 4. And this is 1. This would be square root 2 over 2. And this would be square root 2 over 2. Does this make sense? Because if you multiply this times square root 2, if you multiply square root 2 over 2 times square root 2, you get 2 over 2, which is 1. And that's the rule of the 45, 45, 90 triangle. And so sine of pi over 4 is just, what is this? Square root 2 over 2. And same with cosine, because it's the same exact thing. Okay, so going back to the full unit circle, as you can see, I wrote degrees in here too. And I cleaned it up a bit, so you can use it as reference, I guess. Just to recap, how do you get from degrees to radians? Let's say you have 135 degrees and you want to get to radians. Of course, you can just look at this, but I mean, if we're not going to cheat, so okay, so what are you going to do? You multiply times the radians, so that means there has to be pi, so pi over 180. And you get 135 pi over 180, and as we can see from that scribbled out thing, this simplifies to 3 pi over 4. Yay! Okay, so how do you get from radians to degrees? Well, let's just use some random radian number, 7 pi over 4. 7 pi over 4. you have to get to degrees, so that means that you don't have a pi in the thing. See what I mean now? So you have to multiply by 180 over pi because you want the pi's to cancel out. And this leaves you 315 degrees. So it's as simple as that. All you have to do is remember to use either pi over 180 or 180 over pi. And just remember the placement of the pi is whichever one you choose, sort of. Like that should help you. Okay, now if you need help labeling the unit circle because they're going to ask you to fill out like a blank unit circle, it's pretty easy. What I do is, okay, remember how we established that this was square root 3 over 2 and this was 1/2 and this was 1, right? And for pi over 6, it's basically the same triangle, it's just flipped because instead of 30 being here, it's now here. So this would be 1, this would be square root 3 over 2, and this would be 1/2. So as you can see, sine of pi over 6 is 1/2. And sine of pi over 3 is square root 3 over 2. Cosine of pi over 3 is 1/2. And cosine of pi over 6 is square root 3 over 2. So they're the same values because they're just rotated. So what I remember is square root 3 over 2 is the longest one. It's just the longest one. And 1/2 is the shortest one. I mean, like before you took this course, you probably had no idea there was such a big difference between square root 3 over 2 and 1/2, but there sort of is. So I just remember square root 3 over 2 is always bigger than 1/2. So just remember that. And then for the square root 2 over 2, like if I drew it here, I guess because that's blocking your way. So this would be square root 2 over 2 and square root 2 over 2. So what I remember is every time you have square root 2 over 2, it just means that the x and y are the same. Like it has to be the same no matter what. And so it has to be one of the things over 4 because only the ones over 4 have the same x and y. Everything else has a different x value and a different y value. If you get what I mean, like, because it's the same, like it looks like a square sort of. Well, everything else is like a rectangle or just like a line or something like that. This is just 0 and 1. This is 1 and 0. So the only two that are the same are square root 2 over 2 and square root 2 over 2. So that's something over 4. Pi over 4, 3 pi over 4, whatever, just something over 4. And yeah, there's another trick too when you're doing the tangent. Every time something is equal, like tan of something equals to 1 or -1, you know it has to either be this, pi over 4, 3 pi over 4, 5 pi over 4, or 7 pi over 4. And you can tell which one it is because if it's 1, that means when you divide something over something else, you have to get a positive number. So the only way you can do that is if you divide a positive and a positive and a negative and a negative. And the only two quadrants that satisfy that are quadrants 1 and 3. Oh, another useful tip is if you get mixed up on how to number your quadrants, just draw a huge C like this. Ooh. Because you go 1, 2, 3, 4. So this is 1, this is 2, this is 3, and this is 4. But anyway, yeah, so you only get 1, you only divide into a positive number if both of them are positive or both of them are negative. And you only divide into a negative number if one of them is positive and one of them is negative. So, like, as you can see here, the y is positive, but the x is negative. And here, the x is positive, but the y is negative, if I drew a triangle like this. And then these are both negative, and these are both positive. So, yeah.